Okay, welcome back. Any Physics here. I'm going to analyze the third scenario, and that is where they drop a much heavier upright piano through the roof or towards the roof and see if it crashes through. You saw in the first scenario they had an upright piano 700 pounds, 50 feet, it didn't make it through. The physics was right. I think Grant was wrong. Grant was thinking it would go through. The second scenario was a grand piano. It may have surprised them that the legs went through, but it didn't surprise us, right? Because we computed the pressure and it far exceeded the 2,200 pounds per square foot static load. Okay, so let's see. Let's take a look at the third scenario.
Now, the first time we tried this, the upright piano weighed about 700 pounds. We've upped the weight of this one to 2,600 pounds, or 3.7 times more.
It seems to be holding the sand. You guys want to get in your position?
Additionally, we're raising our height from 50 feet to 75 feet.
Gonna raise up right from there.
That's going to result in an impact force of over 55,000 pounds. Now, bear in mind, that roof is only rated for a static load of 2,100 pounds. There's no doubt about it. This thing is going through.
All right, we're clearing the trees.
Now dangling at 75 feet above the roof, it's time for the final movement as this myth faces the music.
All right, so this is heavier piano from a higher height. In 3, 2, 1.
Okay, so let's analyze this. Definitely should create much greater force. They've taken it from 50 feet to 75 feet. They've increased the weight 3 times. Okay, so we're going to have to reanalyze this. Okay, so the velocity is going to be much higher. So if you remember from video 1, I showed you an equation. 2 times 32 times the distance it falls in feet will give you the velocity of the impact. Okay, when you compute that for 75 feet, it's now much larger at 69.3 feet per second. Okay. So we need to know the acceleration because we want to compute the force. So acceleration is equal to the change in velocity over the change in time. So the velocity is going to go from 69.3 to 0. So 69.3 divided by 0.1, the estimated time to bring it to a stop. And that's going to be an acceleration as it comes to a stop. Some call it deceleration of 693 feet per second squared. Okay, if we multiply that by mass of this larger piano, we're going to get the force. Okay, so F equal ma. Okay, the mass, as I showed before, is going to be the weight in pounds divided by 32. Okay, so it's 2,600 pounds divided by 32 feet per second squared. That'll give us mass in slugs. And multiply that by acceleration, 693. And that is going to give us a force of 56,341. Okay, 56,341 pounds of force. Okay, so they estimated 55,000. Okay, so we agree. I agree with them on that. Okay, again, they've been quoting the static load as 2,100. Previously, I think they quoted it as 2,200. You know, about the same. But they've been quoted in terms of pounds, where static loads are typically quoted in terms of pressure. So pounds per feet squared. Okay, so what would be the pounds? So we can't compare this to this. Right, we've got to compare pounds per square feet to this. So we want to compute pressure is equal to force divided by the area of the base of the piano. And that is 5 by 2.5. So the force is going to be 56,341 divided by the area, again, is 5 feet by 2.5 feet. Okay, and that gives us a number of 4,507. So 4,507 pounds per square foot. Okay, so that's going to be definitely quite a bit bigger than 2,100 pounds. 2,100 pounds per feet squared. So definitely we would expect this piano to go through the roof. Okay.
Whatsoever. That's the hole in the roof.
Okay, so physics was helpful, predicted what happened, and the prediction was correct. And so, very entertaining episode. Very entertaining, great physics. I'd highly recommend you watch the whole thing. Again, it's household disasters, and the other two parts of this include putting suntan lotion on put you at greater risk for catching on fire if you're grilling something out. It's really interesting. And then a really bizarre myth they challenge in that, or they analyze in that episode, is whether a water heater, right? If there's a fire in the house, would they heat the water heater to such a point that would actually explode and put out the fire? So that's really fun, really entertaining. I love Mythbusters. I've watched so many episodes, and I analyze the physics of a lot of them. And I'll come back with even more episodes that I analyze. Thanks for watching, and please subscribe. Thank you. Bye-bye.